Welcome back to class of numerical analysis, and today we are going to look at solution of a transcendental equation by using bisection method. So we have an example of a question which is find the positive root between 0 and 1 of the equation x is equals to exponential to negative x to a tolerance of 0.05%. So we have find the positive root between 0 and 1 of the equation x is equals to exponential to power negative x to a tolerance of 0.05. We have the solution. You start by writing down your equation, which is x is equals to exponential to power negative x. So this one is the reciprocal of 1 divided by exponential to power x. So we have our equation as x is equals to 1 divided by exponential x. Then you cross multiply. You will have x multiplied by exponential to power x is equals to 1. Our equation will be x exponential x. You bring the 1 to this side, it will be minus 1 is equals to 0. So our equation will be x exponential x subtract 1 is equals to 0. So this will be our equation up to the end. So let's do this. Solution. Given that the root, we've been told that the root lies between 0 and 1. So we have f of 0. When we replace 0 to our equation here, it will give us a negative approximation. So this one is a negative approximation. Replacing 1. In our question, we've been told the root lies between 0 and 1. So replacing 1, when we replace 1 to our equation above, the answer will be positive 0.3678, which is a positive approximation. Then, having found the 2, therefore our root lies between 0 and 1. Finding our first approximation, which is x1, it will give us, so we have 0 and 1. So we have 0 plus 1 divided by 2, which will be is equals to 0.5. 0.5, we are going to replace 0.5 into our equation to find the next successive approximation, whether it is positive or negative. So we have f of x1 is equals to 0.5 exponential 0.5 subtract 1, which will give us 0.1756, which is a negative. This is a negative approximation. So we have the next root will lie between, this is negative, and in the first one we had negative and the positive. So, and our root will always lie between a negative and a positive. And because our successive approximation here is negative, it means 0.5 is a negative root. So we are going to use 1, which gave us a positive root, and 0.5, which has given us a negative approximation, to find the next successive approximation. So we have the root will lie between 0.5 and 1. We have 0.5, which has given us negative, and 1, which has given us a positive approximation. So x2, our next successive approximation, x2 will be given by 0.5 plus 1 divided by 2, which will give us 0.75. Replacing to our equation, it will be 0.75 exponential 0.75 subtract 1, which will give us 0.5877, which is a positive approximation. It is a positive approximation. So our next root, the root will lie between our positive, we've gotten a positive approximation, so it will lie between 0.75 and our immediate negative approximation, which was given by 0.5, So our next successive approximation will be given by 0.75 plus 0.5 divided by 2, which will be 0.625. Replacing to our equation, it will be 0.625 exponential 0.625. And remember, I told you in our previous video that your calculator must always be in the mode of radius. So 0.625 exponential 0.625, you subtract 1, it will give us 0.1676, which is a positive approximation. Being a positive approximation, therefore our next successive approximation will be given by 0, or rather the root will lie between our positive approximation, which has been given by 0.625, and our negative. Remember, our immediate was positive and the latter was a negative approximation, which was given by 0.5. So our root will always, or should always, lie between a positive and a negative approximation. Therefore, our next approximation will be given by 0.625 plus 0.5 divided by 2, which will be 0.5625. What about when we replace 0.5625? Is it going to give us a positive approximation or a negative approximation? So we have f of 4, x4 will be is equals to, you replace 0.5625 to our equation, and our equation was x exponential x minus 1 is equals to 0. So we have 0.5625 exponential 0.5625. You subtract 1, it will give us negative 0.01278. 0.01278. Therefore, since this one is a negative approximation, it means that it will be a negative and the immediate positive. That one is the negative approximation. We were given by 0.5625, and our immediate positive. When the sign changes, you change the values that gives you the approximation. So we have this one, the 0.5625 has given you a negative approximation. Therefore, our successive approximation will be given by the root will lie between 0.5625 and our immediate positive, which was given by 0.625. Therefore, our next successive approximation, that is x5, will be given by 0.5625 plus 0.625. You divide by 2, which will give you, allow me to use a calculator, 0.5625 plus 0.625 divided by 2 will be 0.5937. Replacing it, when you replace it, replacing to our equation, it will be x5, it will be 0.5937 exponential 0.5937. So you subtract 1, it will give you 0.07528, which is a positive approximation. A positive approximation. Therefore, the root will lie between 0.5937 or 38 to 4 decimal places and our negative. Our negative was 0.5625. 0.5625. So our successive approximations will be, we are at approximations 5. So our successive approximations will be, for x6, it will give you 0.5781. x7, we should give you 0.5703. x8 should give you 0.5664. x9 should give you 0.5684. x10 approximation, x10 should give you 0.5674. Then we have x11 should give you 0.5669, x12 0.5671. And remember, we were talking about 0.05% tolerance. How to find a tolerance or successive approximation using tolerance? You use the formula. We have x2 minus x1 divided by x2 times 100%. So from our solutions, we had x2 as 0. We had it as 0.75, our x2. This is our x2 here, 0.75, and our x1 was 0.5. So x2 minus 0.5 divided by 0.75 times 100, which should give you a percentage of 33.33%. When you look at this percent, 33.33% is greater than 0.05%. And when you use x12 minus x11 divided by x12 times 100%, we have 0.5671 divided minus 0.569 divided by 0.5671 multiplied by 100%, we have 0.035%. So 0.035% is less than 0.505%. So that means that our successive possible approximation is 0.567 in 3 decimal places. For example, if we look at our successive approximations, we have for our approximation x11, we have 0.5669, and we have for 12 is 0.5671. When you put the two approximation into 3 decimal places, we have 0.567, and this one is 0.567. Then it means our possible positive root is 0.567, having a tolerance of 0.035%, which is less than 0.05%. I hope you enjoyed the class. Practice. Thank you.